Welcome back to Air Quality Matters and part 2 of my conversation with Ian Mawditt. Perhaps we've been dancing around the subject a little bit, but I think at some point accountability's got to be brought to bear, and certainly in jurisdictions where you're seeing it a little bit more advanced than perhaps the UK, Ireland being one example of that. The approach that they've taken there is to simply bookend the process and leave the supply chain to figure out the bit in the middle. So you have a responsibility for compliance to regulations on the design. So the person that designs the ventilation needs to be competent to do a design, and that design is the thing that meets the regulations. That's the person is responsible for making sure that the ventilation design is capable of meeting the standards. And then at the other end of the process, you have third-party independent validation of the ventilation system. So that person isn't having an opinion on compliance. They're simply checking at the end of the process that ventilation system meets the design. It's the design's job to be compliant. The independent inspector is checking that what is happening on site meets that design. How it got there, that's up to the industry to figure out. And in theory, what happens is that person submits a document. They're not given an opinion on compliance, but the people responsible for compliance of that building now have a piece of paper that says that is doing the flow rates and is compliant with the design. And that you've seen that shift, the acceleration of quality on site. Now, it's still early days, so we don't know how that's going to bear out. But we see similar practices in Belgium. They have a system there where you have a design that's compliant with the regulations. And then at the end of the process, an independent party will come and inspect a certain percentage of all new properties and check that the person that's doing the commissioning in that case, it is doing the right job, but checking that the numbers and the system is meeting the original design. Again, not giving an opinion on compliance, just making sure that what's being delivered was what was designed. It's quite a simple leap, but the challenge is you've got to have the infrastructure on the ground to do that. So I think we've seen in the future, the latest Future Homes consultation and the building standards revisions, much more focus now on commissioning. And it seems to be very clearly worded and the requirements are quite clearly laid out. So there's no excuses, I don't think, on what the expectations are of what we expect to find. The question will be, how will that be policed? I think. There's still a gap there, isn't there? I think, to be fair, from commissioning to somebody checking that that's correct, that there's some paper trail. As you say, building control don't have the expertise or the manpower to be out on every site with the wind vane anemometer checking flow rates of ventilation systems. There has to be a paper trail and a way of following up that polices this adequately, doesn't there?
There does. You're absolutely right. And the focus at the moment across Part F and also Part L, certainly the aspects I've been involved with, are around performance gap. And I think to get to a point, the Future Home Standard, like say, is out for consultation. The interim standard, Future Home Standard, came into force in 2021, so that's the current edition of Approved Document F. And yeah, you'll have seen the consultation draft of what we're proposing in the Future Homes Standard version of Approved Document F, which is due to come into force, all being well, in 2025. And a lot of the guidance in the current version and the consultation version are there to try and address that performance gap.
It comes back to the point, doesn't it, of ultimately the regulations. I mean, I see very little change in the last 4 or 5 regulations, notwithstanding the changes in how it's written and the systems approaches versus the performance-based approaches. Ultimately, the regulations aren't asking for anything different. They're asking for you to achieve adequate background ventilation, adequate exhaust ventilation, adequate purge ventilation, and some other stuff. And principally, the commissioning process, as it's been defined in the latest revisions and in previous revisions, have just been improving on defining, checking that. But you can only go so far with that document. I don't know how much more clearly regulations can define what the expectation is. At some point, you've got to go from the intent and the expectation to delivery. And it's that gap. It's not the job of the guidance document to address that gap. That comes down to other regulations and building control and the supply chain and those collective accountability to deliver that. That's the bit now that I don't know. If you were given, like you say, if you were asked to say, well, what would the next government do, or if I was to be rewriting this again in 5 years, what might the next things be? I don't know if I would see, if I was looking at that consultation document in 5 years' time, whether I would see much change in that part of it. Because I don't know how much more clearly you can describe the need to provide the right amount of air for a space, So at some point, it's got to be handed over to somebody else, right? That at some point, this piece of paper has got to be implemented. And it seems to me that's where the gap is now. It's not because it's a really fuzzy, confusing document and nobody knows how to interpret that really odd bit in 5.2 or 7.3 or whatever it is. Like, it's pretty clear. So it's an implementation problem, isn't it?
It is. I mean, the approved document contains all the information you need, and as you say, it's very clearly set out. And the developments over the last few years, and particularly, now the consultation draft, is trying to provide further guidance on how to minimise that performance gap. But still, delivering a compliant building that meets all of those requirements is something that the expectation is on industry to meet the requirements. The approved document for ventilation even goes further than many other approved documents. There's even a template for commissioning sheets and test records, and everything you need to submit to building control is there. It's all laid out, saying, fan flow rates split out into all the different variants of ventilation systems you can put into a home. So it's not a defense, I think, to say, oh, we weren't sure what it was we were supposed to deliver. But still, the enforcement of that, anyone can fill in a document, right, and just put in a number. And let's hope there isn't gaming, but there still needs to be a provision to ensure that gaming isn't happening, and that the intent is there for those designing, installing, commissioning, that they are meeting that regulation. But still, to have someone checking that in the current process, that there isn't a framework yet, other than using building control. But what is happening more over recent years is we've got people like the BCTA, for example, the Building Compliance Testers Association, they are now launching courses, require their members to sign up to their scheme, and that is going to, well, I think they launched last year, if I'm correct in saying, that the different courses for installers and a different course for commissioning engineers. And I can see in time that there'll be a need, might not be driven through regulation, but maybe encouraged through better registration of ventilation schemes in homes, ventilation systems, that there'll be a need for installers and commissioners to sign up to that type of scheme. And that will then allow every ventilation system installed to have a traceable commissioning document. And the BCTA scheme that I've seen actually is quite impressive in that they have a database of all ventilation fans on the market. And if someone's putting in a number that doesn't quite meet the ability of a fan, for example, to meet that particular number, then that will be picked up as part of the scheme auditing. So there are movements in this area. Like I say, it's not necessarily. You could say regulation is a driver. Certainly, trying to, and that's what regulations try and do anyway. All aspects of regulations, you set the rules, and you expect industry to come up with the means to meet those rules. You can't look to government and say, well, okay, it's on you to make sure that we comply. It's the other way around. So, I'm very pleased to see schemes like this coming available now, and way too early to tell if what the success of those schemes is going to be. It's a different approach to what you've outlined in Ireland, but I think there's, if we look at all aspects again of building regulations, A through to O, that it now is, that's quite a lot of. We're focusing on part F here, but to change what you're saying here won't apply to ventilation; it will apply to A through to O. So that's way above my pay grade to resolve. But but the intention is always, I think, to encourage industry to take up the challenge here.
And I think it's important to say that some of your reservation to comment is both because we have a document out for consultation at the moment that you have been involved in, so you have to be mindful in what you say during a consultation process, but also not to be unfair to anybody. Like you say, that the risk is, and the easy solution always is to blame building control for everything, because they should be policing everything. Why are they allowing buildings across the line that don't comply with this, that, or the other? But that's the easy way out. That it's a much more nuanced position, really, quality of outcome in the built environment that has to take account of the entire supply chain. And to be fair to the supply chain, whenever it's pushed, it generally responds pretty rapidly. We've seen it time and time again with PPE and safety and scaffolding and, like you say, air tightness. We see it through the lens of being in the storm, and it seems like it can take a long time to improve. But actually, these changes happen quite quickly sometimes, and for the better, because construction is inherently quite a solutions-driven industry. Very rarely on a building site you go into a project management meeting and they're politically thinking about how to dart around a problem. It's a solutions-based environment. If you lay an obstacle in front of a construction process, they'll find a way to deliver, and that's how it works generally. So when regulations improve, if they know they're going to be held accountable for it, ultimately, you will see a change in the supply chain. They will step up, generally speaking. Is what I've found over time, anyway.
Sure. No, I've seen that through my time, last 15 years or so, working in the development of Part L and Part F. That as soon as consultation comes out, where you're proposing a new method, or a different type of ventilation system, or my work on Part L is also about the insulation of buildings, and over the time, I've seen insulation manufacturers, ventilation manufacturers develop quite rapidly to deliver. They might whinge like mad during the consultation period, and but it's but equally, personally, and I should also clarify that, particularly as we're out at consultation for the future home standard, that anything that I talk about here is my views. I'm not representing government in any way. But personally, I really value the consultation process, because we do hear industry's views, and it's interesting to see, basically there's two sides of the debate, where you may have some proponents of industry saying we're pushing them too far, and then we'll have other people who are more, maybe climate activists that are saying we're going far too slow, and we need to ramp up much more quickly. But providing all of the responses that you get in a consultation are respectful and informative, then I find it very interesting to hear the wide range of views, and they do get listened to. If you look at the Future Homes Interim Standard consultation and look at the government responses on Part F, there were changes made post consultation because of some of the feedback that we received. So we do listen, and we do try and evolve and find that balance, really, where we, my colleagues, or clients really, but I see them as colleagues. They're incredibly hardworking people in the department, very determined, and you know, uh, it's a privilege to kind of work on this, in this field. To see uh, just how driven they are to try and get things over the line and make sure that there's fair regulations delivered for all. So yeah, it's a really good place to it's nice to be inside the tent and to help try and inform the development of this work.
One bit of insight I'd be really interested to get your perspective on. If people read the consultation, one big change they'll probably see this year, one of the few actually, has been the requirement for static pressure testing of ducting. Where's that come from? What's driven that, and what are your hopes for the inclusion in that to better outcomes? Because I think you hinted at it slightly earlier, and you said a lot of the problems that you've been seeing in ventilation systems has been ducting with systems. So I'm guessing that the requirement to be looking at pressure losses in ducting is something that you're hoping will improve that.
Yeah, it is. I think this comes from there's work that's been done over the years, and in the build up to the Future Homes standard development work, the Future Homes Hub, which is an organisation, um, it's led by industry, developers, manufacturers, and governments are part of the panel. Um, it's and part of their remit was to have different technical working groups, one of them being ventilation. And one of the outcomes from that work, which was to help us inform what we were going to do for the future homes standard development, was about performance gap of ventilation. But we're still seeing, as we've said a number of times in this podcast, that you know ventilation systems often don't deliver the airflow rates, and if they do deliver the airflow rates, they're often too noisy. So And why is that? One of the main reasons in a ducted ventilation system is the ducting is inadequate. It might be undersized, might be lots of flexible ducting used, basically too high a resistance in the system. And so the proposal is really to say, well, okay, if ducting is the weak link, it's the one thing where there is no test requirement at all. So all we're expecting currently of commissioning engineers to do is to measure the airflow rate. So now there's a proposal to say, well, if ducting is the weak link, then we need to understand what that ducting is doing, measure it, find out what the resistance is in that ducting. And the proposal sets out maximum resistances or maximum static pressures for the for each leg of ducting, whether it's an MEV system or an MVHR system. So that's what we're setting out to propose as a new test, and as part of that, a measurement of the electrical power that's being consumed by the fan. And with the static pressure measurement and the electrical power measurement, you can get the specific fan power, and we can get a real specific fan power based on how that system's being commissioned. So it gives you two things. It gives you the efficiency of the system. How efficient is it? And that then ties into Part L efficiency requirements. But also, is the ventilation system likely to be satisfactory, both from delivering the required amount of airflow and the occupant comfort from a noise comfort point of view. So that's what we're, I guess, setting out to address there.
Yeah, interesting. And it leads on to a point about the data, actually, for me. I made a note on this earlier, is that if you're clever with this stuff and you record the right things, we can really open up more performance information on our building stock. If we're capturing the floor area and we've got the flow rates and we've got the static pressure and we've got the watts per litres per second, all of a sudden we're starting to, and we've got air tightness of a dwelling and occupancy, we're starting to build a picture of the performance of that space, the intended performance of that space and what's being measured. And that's enormously powerful, because at the moment there's huge gaps beyond the academic study of performance of particular projects. It's very hard for us to get a picture of the real world performance of some of these spaces. And I know that's a big focus of the future home standards, is the improvements of things like the standard assessment procedures. And the more of this data that we can have, although it might seem like quite an obligation for people now to measure static pressure on a ventilation system, not only could it be a critical piece of the jigsaw puzzle for the performance of that ventilation system, it's another jigsaw piece in the overall performance of that space, isn't it?
It is, and we're moving into an era where we have more and more data. We're data hungry to get the evidence, and anything we do change on regulations, by the way, or the guidance around the regulations, needs to be evidence based. So the more we get, the better the better the guidance will be, in certainly for my work, but on a wider scale, having greater amount of data on buildings, it's a gold mine. If we can have, we're seeing smart meters and smart thermostats. If we could have, as part of that data, temperature data, we can get energy data, humidity data, and if we know what a ventilation system is commissioned to do and what the specific fan power is, and we have that, on a large scale, then understanding the context behind that data, which is usually a massive challenge, particularly for meta level studies. It's like, well, okay, we've got all of this energy data, we've got all this temperature data, but what does it actually mean? And if we have extra bits of data to, do with fan power or static pressure, and then also information from users as well, about their experience on using ventilation systems, or why did they switch it off, or whatever. Then that really helps us to understand better and develop products better, and develop guidance more tailored to the products that are available on the market.
Yeah, and you a beautiful segue, by the way, into one of the questions I had for you, which was, our conversations are predominantly about ventilation, as people would imagine. But you study a lot. You're involved in projects that look at quite a wide range of performance of buildings, and you've been doing it for a while. You've seen the evolution of technology in that space, the ability of sensors to communicate more effectively over time. But importantly, you've been on the ground deploying technology to answer questions about the performance of the space. At the moment, we're in this context where we're seeing rapid deployment of environmental sensors and other sensors into our built environment. They have academic uses, but predominantly their deployment now is because they have commercial viability. They have a purpose beyond research, and they're delivering solutions to customers and suppliers of products. So we're seeing environmental sensors in heat pump thermostats. We're seeing environmental sensors going into social housing smart thermostats. They're everywhere. And it's my contention, within a decade, there's probably not many spaces we'll occupy that won't have some form of monitoring happening in them. But there's a big gap, isn't there, between just collecting data and the value of data, the context, the questions you're trying to answer, and finding utility in that data. What have you found over the years deploying sensors and monitoring environmental conditions that you think that space could learn from? What does it need to be aware of when it's thinking about the deployment of these sensors in spaces generally?
That's a good question. I think, for me, the number one thing in any data collection, whether it's a single home or thousands of homes, is context is everything. The amount of times I've been involved in studies, and I go back to 2010, when I was involved with the Building Performance Evaluation Program run by Innovate UK, or Technology Strategy Board as it was then. And my role was to supervise teams that were going out, they were funded to study a building that they had designed and built, and then it would be a 12-month study of that building to look at a range of performance evaluation, whether it's energy performance, whether it's comfort, or ideally all things to do with how a building performs, productivity, even in office buildings. And the main thing that I tried to get across to those teams that were funded to go and purchase or hire test equipment, monitoring equipment, was set out your research questions. What is it that you want to find out about this building? Because there's no point in deploying lots of expensive equipment and then at the end of 12 months you download all of this data and you're just drowning in literally millions of digits of data, and trying to untangle it and make sense of it. So work out what it is you're looking to answer, and then find out what information you need to answer. So don't go and measure everything, just measure what you need to measure, and collect data on the building that you think. Often, if I'm monitoring a building, I'm collecting heaps of contextual data about, the geography of the height of the building, the exposure of the building, the type of construction, how many residents live in there, type of ventilation system, the type of heating system, how it's used, all of these things that are soft data rather than the hard data that you collect on your data loggers. And that is so vital when it comes to the analysis stage, and then relating that the number crunching that you have from the data logger data to then apply it to the context from that building. So context is incredibly important. But I think now that we're moving into an era, one of the biggest challenges is doing field studies, is recruitment and trying to ask people to, can you enter their home and start installing scientific equipment for a period of time. Whereas, that's still going to be needed for some time yet. But with smart devices available on the market in everyone's homes, I used to say that every front door should have next to the doorbell, should have a USB port. So you could just, an engineer, a bit like when you take your car to a garage, they plug it in, the technician plugs it in and finds out exactly how you've been driving that car since its last service. Wouldn't it be great if you could have that? And actually, as I say that, you realize that a lot of that information is available. It's not a USB port, but it's on apps on smartphones. If you've got a solar photovoltaic installation and a smart meter, and you can have an app that tells you exactly what your energy draw is and what your energy gain is and how it's been distributed around the home. And we're seeing that now with smart meters connected to smart thermostats, so you can then get information on the comfort conditions in the home, how occupied the home is, what the occupancy patterns are. So, and I have to put all the GDPR issues aside, just for brevity here, but assuming that you've got the right permissions in place to access that data from the residents, we're entering a period where we've got an amazing amount of data available to us. So now it's a case of coming back to ventilation. One of the difficult things we don't currently have is an ability to dial into any of this data and say, well, what's the ventilation like in these homes? Because that doesn't come, from directly anyway from any devices that are currently fitted into a home. So I think there's going to be a need for development there to try and understand, with data that we have available to us, like temperature and humidity sensors and energy data, that we might be able to start building up matrices on homes that have this data available to try and evaluate what the comfort conditions are like, and then relate that back to the ventilation rates. Not in terms of precise figures, whether that property's got 26 litres per second or whatever, but just, good, bad and ugly. A bit like how Peter Rickaby dealt with the whole Thamesmead study, having that kind of risk register. That's what we need, not just for Thamesmead, but the entire country. Every home should have that kind of risk register grading. And that's what we can get with big data.
There's a couple of ideas to unpack there, and one of them is I do like the car analogy, actually, and I use it quite frequently. Not so much because, I think people understand now that when you take your car in for a service, one of the first things they'll do is they'll plug your car in and they'll know the performance of every switch and device in that car, and they can see a failure in X, Y, or Z. They'll even know the viscosity of the oil and how you've been driving it. And there's an awful lot of information at a technical level for a practitioner to deliver a service in fixing your car, right? And that's very analogous to data from the built environment, for practitioners within the built environment to be able to look at that kind of data, to be able to interpret more accurately where things are working and they aren't. But just like your car, that same data is being used to present information to the user of that space in a more simplified format that is useful for them to get the most out of their car. For example, the fuel performance, the efficiency of the car changes how people drive their vehicles. That data is being collected for other reasons for the practitioners to be able to fix fuel pumps and to be able to make, but it's the same sensors. It's just the delivery of that information is different for the user of that space, in the same way that if your engine light comes on, it won't tell you why. You might have to go into a setting to figure out what the problem is. The technician will plug his computer in and will know exactly what sensor's got a fault on it to fix it, but you just need to take it in for a service. And similarly with the built environment, we may well find that data from the built environment is raising a red flag to homeowners that they might need to get something checked. And it will be like you say, someone comes with a laptop, plugs into the USB at the front door and goes, yes, that's the problem, or because traditionally it's been very difficult to root cause a problem, particularly with things like ventilation and air quality, when, condensation, damp and mold being one of them. When practitioners have come into spaces, you've got no idea how the ventilation was performing last week, or last month. Whereas this data increasingly is going to provide that context for people. So that was one thing. The other comment was around, I think if it has utility, that answers a lot of the GDPR questions. People don't mind sharing data if it has value to them as an outcome. And we've found that in social housing particularly, much less resistance to the application of devices that collect environmental data than you'd think in those spaces, because the perceived value to tenants is that this helps their provider of housing provide a better service. So actually the acceptance and the willingness to impart data from someone's own home is much less resistant than you'd think, I think.
It is much less resistant when you're dealing with an individual householder. It's when it's a larger scale study and getting access to energy data on a stock level, well, greater than stock level, on an energy company's portfolio level, to access all of their customers' energy data. That's not a straightforward process. Not just because of GDPR. Since GDPR came in, it's general privacy. That's classed as personal data, energy data. So, that was a challenge. I was thinking, usually when you get over the threshold in someone's home and you've engaged with them and told them what you're trying to do and why, then they're very receptive. So yes, that one's a lot less of a challenge. But kind of coming back to the point though, but I still think now we're already seeing homeowners engage a lot more with the technology that's put into their homes, and a lot of the focus, as I've touched on, is things like solar photovoltaics and battery storage. Every single supplier of those technologies has some kind of app that you can download and put on your phone. But we are starting to see that from an air quality perspective as well. The air quality devices, some of them are a bit gimmicky, but nonetheless, it gives people an insight into what is going on in their home. And it might be measuring VOC, it might be volatile organic compounds, even though it will just be doing the total volatile organic compounds, which is a little bit gimmicky, or can be recorded in that way. But nonetheless, it's a bit of a dashboard to, and it's kind of what they've done in, like I said earlier, about the Scottish regulations, using CO2 as a metric there, as a proxy for air quality, and just having a simple red, amber, green indicator. Or now I'm seeing, like I say, devices on people's smartphones with an app connected to a sensor or sensors in the home. Now, as long as those can start connecting to a ventilation system to enact to do something with that. Rooms turned red. You need to make it green again, and therefore the ventilation system can kick in and do what it needs to do. The technology is already there. It's not that widespread at the moment, but it is there.
And that's part of the problem.
Think,
it's part of the problem and the solution. I think there is a little bit of a just because we can, we should going on at the moment. So you see the deployment of sensors in spaces where they haven't, because they don't understand the building physics or the questions they're trying to answer. You find the placements of, temperature and humidity sensors placed above a radiator or by a window where they're going to get sun on them. All the classic stuff that you and I have seen over the years. Like the cheaper those products get and the more deployable they get, the more propensity there is not to think through the what am I actually trying to get out of this sensor. There's a little bit of a risk there. But the other side of that coin is that data drives data. And what we're increasingly seeing is you lose control of the narrative if you're not involved in this data collection. So as I would say to manufacturers, you need to start thinking about collecting data on the performance of your ventilation system, because what's going to happen is people are going to start to ask you uncomfortable questions about the performance of their space. And if you don't have the data to answer that, it makes your life harder and harder. So what you tend to find, what I'm seeing anyway in the industry is, as we start to see pockets of data popping up in the built environment, it enables people to answer questions that could only be answered with more data, or very expensive consultancy-based somebody coming in and doing proper type tests. So that there's a kind of a natural driver to this, I think, that's starting. And I've experienced it personally over the last 5-6 years. I'm starting to be asked different questions now than I was asked half a decade ago. People are saying, look, my CO2 is regularly 1,800 parts per million in my bedroom. Like, is that good? Like, how do I know? And I noticed on Saturday it was worse. And, people have context that they never had before. Whereas before they'd have been coming to you and going, I think the ventilation in my bedroom's a bit poor. What do I do about it? Now they're coming with information. And if you're a manufacturer, you've got to answer that now. You're going, well, okay, I'm supposed to be delivering adequate ventilation and I've got a bedroom that's got 2,500 parts per million in it. Now, it might be the undercut, might be something nothing to do with you, but you now have to answer that question. You didn't have to answer that even 5 years ago.
You do, but one of the questions you need to come back with is, well, what air quality are you after?
Yeah.
Because you can fit a small fan or a large fan, and you'll get two different air qualities for that size room, and depending on the number of occupants. So I always find it interesting with Scotland setting 1,000 parts per million for bedrooms, when actually their minimum ventilation rate, if you did a steady state calculation for a double occupancy room for the minimum ventilation rate that they ask for in their technical standards, would actually deliver a CO2 level of about 1,800 parts per million.
That's right.
Yet they have an indicator in their bedrooms that are required under the regulations to inform a resident with a simple indicator going to red that it's exceeded 1,000. Well, it's not actually balanced with what you're asking for. So yeah, you can have if you want 1,000 parts per million in a bedroom or less, then yeah, you can provide that. But it depends on what the manufacturer is asked to provide. If they are asked to just provide to the minimum standard, and then they get a complaint from a resident saying, actually, it's about 2,000 parts per million in my bedroom and it should be 1,000, saying, well, actually, did you ask for 1,000 parts per million when you bought the fan from us? Yeah. So there needs to be a bit of a tie-up between what the data says and what was originally asked for.
And I think that will be a natural progression in the conversation over the next decade or so will be, as we get better and cheaper ability to measure air quality outcomes in the spaces we occupy, it will raise different questions and will enable us to provide different performance criteria than we would have had a decade previously. And the Scotland one is a really good example of that. That's a case of a regulation being implemented because they could. Sensors was cheap. It was at a time that we started to understand NDIR sensors. It was part of COVID. Like, why not chuck them in every master bedroom? And if 1,000 was the number that was being floated around, but there were unintended consequences of that number, and most typically because when the light was going red, you're asleep and you couldn't do anything about it anyway. So, there are all sorts of questions that come from the data that will have to be answered, and that's a healthy conversation. But at the moment, we still aren't achieving the basics, which is the aerolic, the ventilation performance of spaces. But this new wave of data is going to be bringing even more focus to bear on that, I think, because
I think it is, and also on top of that, recently we've had a pandemic, where the consumer is now more aware of their indoor environment. Things have gone a little bit back to normal. Don't have so much window opening at this time of year in winter as there was a couple of years ago. But nonetheless, the awareness of the consumer is heightened, and during the pandemic, the sales of little devices, indoor air quality devices in homes, there was an exponential increase in sales from Amazon on those sort of units. So, and people will be using those and are more aware of what is happening in their homes. And if that means that they go and open a window because it's gone red or given a number that's above a threshold, then that's a good thing. It doesn't really matter to me too much what the accuracy is there, as long as it starts. The main benefit from my point of view for those devices is raising the consumer awareness. And we're entering that era, and now we're building more airtight homes where they can get stuffy if the ventilation system's switched off permanently. And that is one of the things, actually going back to the building performance evaluation program. There was a few properties there, one of them being a passive house project, where that was a MVHR system as required by a passive house. Very, very airtight passive house as well. I know all passive houses are, but that was particularly airtight. I think it was less than 0.5. And I can't remember exactly what happened. I think it was when they were doing one of the tests, doing a follow-up air tightness test, that the ventilation system gets switched off for that test. And I think the tester forgot to switch the MVHR system back on. And it took 2 weeks for the residents moving back in for them to phone up the research team and say, "What have you done? Because we can hardly breathe in a house." And their CO2 had exceeded 5,000 parts per million in the house.
Ouch. Yeah.
but it just shows, how quickly the indoor environment can change. So I think, that's an extreme example, but nonetheless, we're building very airtight homes. And if you switch off the ventilation system, it will take you 2 or 3 weeks, before consumers start saying, "It's a bit stuffy in here."
Yeah.
And that's going to drive, I would imagine, along with these devices that tell you what's going on, it will drive a bit more consumer awareness and the change that will follow.
Yeah, and I think from a consumer perspective, this data is very good at highlighting the extreme cases. It provides a red flag, and then I'm looking at a sensor with a frowny face on here because I need to open a window in my office. But what it also does, and as for practitioners, it also helps to answer that grey middle ground when you're going in trying to unpack stuff that is a little bit nuanced, and there are a number of confounding factors that might be impacting poor outcomes. Data can be absolutely critical in unpacking and filtering and highlighting where to concentrate. And that, I was saying this to Pavel Warchok in a podcast yesterday, these low cost sensors are a bit like health wearables. They're really useful for giving general information, extremes of cases. You need to do more steps, your blood pressure's a bit high, whatever. But you should probably go to the doctor at least once a year and get a blood test as well. Like at some point, a professional, it's advised that you get somebody to actually look at what's going on properly. And that's going to be the case in the built environment. These low cost sensors provide a good picture often of what's going on. But at some point, you might need a professional to come in and actually do a proper air chemistry evaluation of what's going on in the space, or measure the actual pollution or performance of the ventilation system to determine why you're getting frowny faces in your bedroom.
Yeah, absolutely. And the data is only as useful as the action that's taken when if you find poor performance, what do you do about it? And in the case of ventilation, there's still a lot of the response amongst consumers will be just to open a window just temporarily, just to change it back to a smiley face again, and there won't necessarily be that follow-up. So yeah, I think professional intervention, whether it's once a year or however often, to ensure that if it is a mechanical system in particular, that it has been adequately serviced and is still doing what it's supposed to be doing. And a lot of the particularly more high-end ventilation systems on the market already have apps as well. They have, even if it's not an app, if it's a wall controller, will tell you when a filter needs changing and needs the heat exchange needs cleaning or whatever. So, and who knows if what's been proposed in the future home standard consultation with the static pressure measurements, you'll soon see fans coming onto the market that will automatically carry out those measurements for you. And so that will then be another reading. Is the ductwork blocked? You can use that data to have a smiley or sad face about the ductwork. Does it need cleaning? Has it got clogged in some ways? So all of that would be helpful too.
How long have you been doing this now, Ian? I've been chatting to you for years, obviously, on this subject, but you started Four Walls how many years ago?
I started originally about 20 years ago on this. So before then, I was a building services engineer, so working on designs of buildings for all aspects of building services. Initially, my original training was in electrical design and lighting and power stations, and then that part of being a multidisciplinary engineer that I changed. I started looking at heating and ventilation designs and supervising the installation on site. And I think really one of the sea changes for me was actually when Part L 2002, I think it was, first came in. I'd long been frustrated about being a designer on a building, seeing that design enacted by the installation contractors, overseeing the commissioning, and then that was it. There was a 12-month defect period afterwards, just to ensure that nothing had completely broken. But I was really frustrated over time that after 12 months of having spent so much time designing and supervising this building during its construction, that we had no idea how it was actually performing. So Part L 2002, I think it was that edition that introduced the requirement for submetering in non-domestic buildings. And I thought this is a great opportunity because now we're putting the infrastructure in to measure these buildings. But then there was no interest from the client side, the building owners, to understand how their buildings were performing. As long as they were functioning, didn't have complaints from the building users about it being too hot or too cold or whatever. We didn't really have much of a dashboard on how the building was performing. So, to cut a long story short, I eventually kind of got out of that and started trying to And that's when I formed Four Walls, really, about 2003, 2004. Um, and it's always been around building performance. And now that's uh, established into its own sort of discipline, building performance evaluation. And that's really what I've always tried to do. Whether it's most of my focus, as you can probably tell on this podcast, is and our conversation previously has been on homes probably for the last 15 years. But yeah, all sorts of buildings. How are they functioning? We've got the information from building management systems in non-domestic buildings, whether it's energy data, temperature data, CO2 data, whatever it is. So yeah, that's really my interest. Really is trying to evaluate buildings for better good. Really, And when I started, the reason I moved more into homes and understanding housing is in that time I was doing a master's degree, and I settled on my thesis being uh, uh, to try and find out the ventilation and indoor air quality in new airtight homes. So it's a bit of a theme here. and um, I thought that was going to be a literature study, to try and look at all of the documentation and, Max Sherman and others that you've interviewed on the earlier podcast of, read widely their publications. But nonetheless, there wasn't anything really about new homes that have been built to more airtight standards, uh, about the air quality in those homes. And so I set out on my thesis to go and get the field data and recruit homes. I recruited 5 developments to actually get the field data. I guess the findings have constantly sort of amazed me about initially about how bad things were, but also about how good they can be as well. So I looked at some interesting developments like BedZ, which is the Beddington Zero Energy development in South London by Bill Dunster, because they've got quite a novel heat recovery ventilation system using passive wind cowls on the top. And at the time, actually, he was getting complaints from residents and others that were saying, well, these don't really work that well. So I went in and did some scientific measurements, tracer gas measurements, and various other scientific tests, and actually proved that they did work. And actually that's quite an interesting. I use BedZ quite a lot when I talk to people, right? Saying, look, this is whether you like it or not, the strategy that they came up with, because it's not everyone's aesthetic cup of tea having a great big wind cowl on top of their roof. But nonetheless, what I love about it is that is very much wearing the strategy of the ventilation system, you know, with bells and whistles on the roof, brightly coloured wind cowls that they turned into an architectural feature. That's someone who put ventilation central to their design. So I love it for that, and I'm glad it did work. But yeah, that's really where Four Walls, I guess, really started, was getting into the sort of detail of how buildings really are performing.
And it's clear talking to you where your enthusiasm is driven from. And I think there's a level of fascination on building performance. Like, nothing is more interesting than getting under the hood of buildings and actually seeing and understanding why things do and don't work. But I think equally, and to counter a lot of the conversations we've had today, naturally, because we've been talking a lot about regulations, it's about driving the sector and improving it. And naturally, there's a lot of talk about underperformance. But we do get this right sometimes. And it's hard to explain what kind of an impact improving ventilation and air quality can have for people. And we see that very often in deep retrofit, the significant change you can see for people's health and well-being and lives that can be generated from a decent living environment is enormous. and a real driver for me personally, and it's been some of the most emotive experiences I've had in the built environment have been those experiences of seeing how you can change people's lives and how you can set a foundation for a quality of life with a good indoor environment that's palpable.
Yeah, absolutely. And the feedback I hear from consumers who do live in a house that's got a decent ventilation system, particularly those who have had some kind of respiratory complaint or some medical complaint that's related to indoor air quality. Not in every case, but certainly those with respiratory conditions, if they've moved from a horrible leaky old home that's letting in all the external pollutants and mold spores and so on that are causing them complaint, to then move into an airtight home with an MVHR system. Again, those that have been put in well and looked after well and are operated. Um, the difference when you speak to these people is makes quite a profound difference to their lives. It's because their symptoms will not necessarily disappear, but they'll certainly be a lot more manageable if their immune system's better able to deal with pollutants because they're living in a home that has got reasonable air quality.
Yeah.
And and that can be helped. That's where MVHR does help somewhat, because you've at least got some filtration. Albeit that the filters that come standard with most MVHR models are there to protect the heat exchanger rather than the occupant, but nonetheless, that they are a beneficiary of that filtration.
Yeah,
It
no,
does help. It helps a
absolutely.
lot.
Listen, Ian, thanks so much for your time today. It's been a pleasure to talk to you as always. We're at 2 hours, and I'm going to cap it there because we could go on for another hour at least. But that I don't know if I'm going to retain listeners for much longer. I appreciate your time. It's been great chatting to you, and we'll talk again soon. Thanks a million.
Thank you, Simon.